excellent video to understand how do we find the equation of tangent line using difference quotient method and interpret it graphically. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll extend the understanding of difference quotient concepts. We'll relate it to derivatives now, correct? We'll find the limit of difference quotient that actually is derivative of a function at any particular point. Limit of difference quotient can be interpreted as slope of tangent line at a point on the curve. Evaluate the limit of each difference quotient and then find the equation of the tangent. Represent situation graphically. It's a very beautiful question in which you will understand how do we start from difference quotient. Two examples are here. One is limit h approaches 0, 4 plus h whole square minus 16 over h. The other one is limit h approaches 0, square root of 9 plus h minus 3 over h. You need to first evaluate the limit, that means figure out what is the limit of this, and then find the equation of tangent, right? Once you've done that, then represent the situation graphically. That is the complete question. Perfect. Now let's try to first evaluate the limit itself. Question number 1. We are to find the limit when h approaches 0 for 4 plus h whole square minus 16 over h. Let us expand 4 plus h whole square. You will notice that if you substitute 0 at this stage, then you get 4 square over 4 square minus 16 over h, right? So if you, let me just write here, if you sub h equals to 0, then what happens? Let's check that part. In that case, you get 4 plus 0 whole square minus 16 over 0. Do you see that? You get 16 minus 16 over 0, which is 0 over 0. So you cannot substitute h equals to 0 to start with, because you get this, which is an indeterminate. And that realizes that there is a factor in numerator and denominator which can be cancelled, right? So that is why what we do is we have to figure out that factor and simplify the expression. So for that, here is one of the techniques, and that is to expand and simplify. So that is why we are just expanding it, right? So limit when h approaches 0 for this particular difference quotient. It is called difference quotient because these are differences of y values and that is the difference of x value. We get limit h approaches 0. When you expand this, you get 4 square minus 2 times 4 times h, which is 8h, plus, and h square. Then you have minus 16 here divided by h. So in the numerator, 4 square and minus 16, 16. So you get limit h approaches 0, 8h plus h square over h, correct? Since 4 square and 16 cancel away, 4 square is 16. So now we get what? We get this expression as equal to limit h approaches 0. You can factor out h now. You get 8 plus h over h and cancel h. So see, this was the factor which was making it 0 over 0. Do you understand this concept? And once you have cancelled that, now you can substitute h equals to 0 and get your answer. So substituting, we get 8 plus 0, which is equals to 8. And therefore, we have our solution, and that is to say that limit h approaches 0 for 4 plus h whole square minus 16 over h is equal to 8. Perfect. That is what you get. So now we have done the first part, and that is to evaluate this particular limit. Now let's do part 2. Getting back to the question, which says limit of difference quotient can be interpreted as slope of tangent line. So we got the slope of tangent line. Do you see that? So we found this limit as equal to 8. At a point on the curve. So the point here was what? This is what you have to figure out. Point is 4, right? Evaluate the limit. So we've done that part. And then find the equation of tangent line. So we have found the limit is 8. Now how do you find the equation of tangent line? So you have to figure out what point we're talking about. So in difference quotient, you will see that the general formula is f of a plus h minus fa, where a is the x value, correct, over h. So if you compare clearly, what do you notice? You notice that the function here is basically x square, right? And now it makes sense, correct? And the value a is when x is equal to 4. Makes sense? Do you compare now all the things? Perfect. So let's take it on a fresh page and then find the tangent and understand its meaning. So we just now figure out that this particular limit, let me rewrite here, h approaches 0 for 4 plus h whole square minus 16 over h is equal to 8. And as you understand, generally the limit is related to gradient, right? Or slope m. And that is equal to limit h approaches 0 of f of a plus h minus f of a. That is difference quotient, right? So if you compare this, you see it is squared here. That means clearly the function here is x squared. Because this fa means at what point you are 16, right? So if you substitute 4 here, you get 4 square equals to 16. Correct? That means the x value is 4 and the y value is 16. You get the idea? So clearly, you have the given information that the gradient m is equal to 8, which is the value of this limit, and the point P on the curve is value x is 4 and y is fa 16. Perfect. So that becomes the given point. Now you have to find equation of tangent. Equation of tangent will be y equals to mx plus b, right? So in this case, slope is 8, right? X value, we'll write again. Let's find b first, right? So y is 16 for x equal to 4. And that helps us to find the value of b, correct? So we can say b is equal to 16 minus 8 times 4 is 32, which is minus 16. And therefore, the equation of tangent is what? Y equals to the gradient 8 x and minus 16. Is that clear to you? So that becomes the equation of tangent. Perfect. Now let's visualize all this and understand what we have done here. So, as explained, this represents a parabola. Let me draw a big parabola here. And on this parabola, we are talking about a line which is tangent at a point. So, and this particular point is 416, correct? The graph is of y equals to x squared. You get the idea. So this point here, the x value is 4 and the y value is 16. And the red line is the tangent line for which we just find the slope, right? So we got the gradient m as the value of this, which was 8. We got the point as 416. And then we calculated that the equation line will be y equals to 8x minus 16, correct? So this is minus 16. Perfect. So that is the graphical representation of the difference quotient limit which you have showed here. So limit of difference quotient gives you the gradient. Since you know the points, you can find the equation of tangent line, and that is how you visually represent the information. Perfect. So that is how we do it. Now it is time for you to do a similar question. Well, in case you want to learn from me, you can always send an email on the address given. Most of my students are doing extremely well. They're right there on the top of their class getting highest marks and awards, like Akshay.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
So I'd like you to now pause the video, answer this particular question. It's a good practice question for you. And this is how we are going to tackle and understand it. We need to find the limit of square root 9 plus h minus 3 over h when h approaches 0. Now, if you sub h equals to 0, what do you get? You get square root of 9 plus 0 minus 3 over 0, right? Which is equal to square root of 9 minus 3 over 0. Square root of 9 is 3. We get 3 minus 3 equals over 0, which is 0 over 0. So always when you are given a limit like this, you should try it out. Sometimes you can find a limit, okay? If sometimes it does, right? If you're looking at a point which is not 9, not x equals to 3, then it will, right? Okay. So let us now see how do we simplify this expression to get rid of the common factor. Perfect. So in case when you have radicals, we adopt the method of rationalization, right? So we'll do rationalization. So in this case, we'll rationalization of numerator. Okay. So we have the limit h approaches 0, square root of 9 plus h minus 3 over h. So when you want to rationalize the numerator, you multiply and divide by its conjugate, which will be square root of 9 plus h plus 3 over square root of 9 plus h plus 3. So when you multiply and divide by the same term, you're not really changing the expression. It is exactly same because you're multiplying by 1. Okay. But this helps us to simplify. In the numerator, you get a minus b times a plus b, right? It's a difference of squares. So we have this as limit h approaches 0. And the numerator, we get 9 plus h minus 3 square. Square of square root will give you 9 plus h over h times all this, which is square root of 9 plus h plus 3, correct? So that gives you limit h approaches 0. And here, 9 minus 3 square is also 9, will be 0. So you get h over h times square root of 9 plus h plus 3. Now you can cancel from numerator and denominator h. That was resulting into this. Do you see that part? So again, we have cancelled the common factor h from numerator and denominator. And now you are in a position to find the limit of this particular difference quotient. Substitute h equals to 0 now, right? So no need to write limit now because we are substituting. So we get 9 plus 0 plus 3, which is equal to 1 over 3 plus 3, right? Which is 1 over 6. So the limit of this function is in fact equal to 1 over 6. So we have found the limit of difference quotient. Now we need to find the equation of tangent line. Perfect. Limit gives you what? It gives you the gradient, the slope at a given point. And what is the point here? The point is x equals to 9, right? So let's continue. We just found that the limit of this is equal to 1 over 6. So that means the gradient m is 1 over 6 and the point of interest is a fa, right? Think like this, right? So the point is a is 9 and fa will be 3. You get the idea? So can you tell me what the function is? We should have started with the function, right? Now clearly the function is what? The function which we are talking about is basically equal to square root of x, right? You know square root of 9 is indeed 3, right? That's a check, right? Is that clear? So you see that you really don't have to get the function. The formula gives you the value of x as well as fa, right? Okay. So let's now find the equation of tangent line. How did I get that? Let me once again give you the complete formula right here. So general formula is limit h approaches 0 for f of a plus h minus f of a, right? Over h. Do you see that? So the value of a is the x value. A is the x value, which is 9 here. Do you see that? Can you compare it straight away? Right? Easy. And the value, y value, at x equals to a, which is 9 here, is given to you by fa. Makes sense? Clear, right? So from the difference quotient, you can easily directly get this, right? We have to evaluate though, since we need to find the slope, the gradient. Is that clear to you? So now let's find the equation of tangent. So equation of tangent. We know what? We know the gradient, which is 1 over 6. We know the point, which is 9, 3. Correct? So the equation will be y equals to mx plus b, right? So in this equation, we'll substitute all the information given to us, which is y of 3, correct? Gradient of 1 over 6, the x value of 9 plus b, which we need to figure out. So it is 3 equals to, dividing, simplifying, you get 3 by 2 plus b. So 3 minus 3 by 2, right? 3 minus half of 3 is what b is. So that gives you the value of b as 3 by 2, right? So we get b equals to 3 by 2. So now you can write down the equation, which is y equals to gradient 1 by 6 x plus 3 by 2. Make sense? So that becomes the equation of the tangent line. Perfect. The function here is square root of x. Let's try to visualize this now. So once again, we know that the gradient m is 1 by 6, since that is the value of this difference quotient. The point of interest is 9, 3. The function, of course, is square root of x. And the equation of tangent line is 1 over 6x plus 3 by 2. So let's try to sketch and understand this situation. So the function is square root of x. Correct? At 3, we have our tangent, right? So let me just sketch a tangent here. Right? Now, this point where it is tangent is at x equals to 3. The y value here, 9. 9. The y value is 3, right? This is the x value. Perfect. And as you can see, the equation drawn is, this is 3 by 2 or 1.5, you can write. And the equation is y equals to 1 over 6x plus 3 by 2. So that is the visual. So you can visualize now completely that the difference quotient basically gives you the gradient, right? Right there. And also it gives you the information about the point. So the point here is 9, 3. You get 9 from here, right? And 3 from there. Do you see that? Point is 9, 3. Once you have the gradient and the point, that means once you have this combination, then you can get the equation of tangent line very easily. Is that concept clear to you? That is how we do it. Perfect. So I hope this is absolutely clear. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'd be great. In case you want to learn directly from me, feel free to send an email on this particular address. You can also check our website for latest updates. Thanks for your time and all the best.